Hey everyone, and welcome to Working on the 21st. Today we're going to talk about the human eye, how humans actually see things, and whether or not it's possible for computers to see the world the same way that we do. We're going to talk about the visual cortex, pixels, convolutional neural networks, and we're going to talk about some of the ways that computer vision and artificial intelligence can today both save lives and put people out of work. So let's get into it. Sight is a miraculous thing. When's the last time you stopped and thought about how amazing it is to see the world around you, or even how vision works? From the time we open our eyes in the morning until the time we go to sleep at night, we're taking in vast amounts of information from the world around us, thanks to a blend of our eyes, optic nerve, and visual cortex. Light reflects off objects and reflects through our eyes, and our eyes transmit that data to our brain at a remarkable speed. We walk around every day with two super high-def video cameras beaming information at 200 miles per hour to our brains. But that's not the craziest part. On top of all of that, our brains can add context to the things we see. We look at this picture and we see that it's a dog wearing a sweater in the winter. That's Molly and she's always cold. It's an odd thing to see, a dog wearing a coat, but alas, your brain is able to make sense of it. How about this? Yes, it's a monkey riding a dog, chasing a goat. Again, it's nonsense, but we can break down the image in milliseconds and completely understand what's going on in the picture. Maybe not in real life. I still have so many questions about this picture. Every once in a while, we're reminded of the limitations of our eyes and our brain, though. We call them optical illusions. I'm not going to ask you if this dress is blue or gold, because I know it's blue and you can't tell me otherwise. But what if I told you there were 12 dots in this image, but your brain can't see them all at once? Want to make your brain really hurt? Watch this rotating mask. This one is tough because your brain knows better, but can't overcome the challenge of seeing the mask convex instead of concave. There are other fun ones, like this child going for a piggyback ride, or this lovely couple. And we aren't alone in this. Other animals have mental barriers between their eyes and their brains that are next to impossible to overcome sometimes. Human vision is a remarkable thing that's been refined over thousands of years of evolution. But other animals see the world completely differently than we do. Not better or worse, just different. Cats have remarkable night vision, as do many nocturnal animals. Some birds have incredible zoom. Some animals can even see different types of light, like ultraviolet, for instance. That's all good and well for animals, but what about computers? How do computers see, or are they even capable of sight at all? Playing an HD video doesn't necessarily equate to seeing the video. When do computers see a picture? When it's stored on the computer? When it's opened? Never? Always? In this video, I'd like to take you through a study of artificial intelligence called computer vision, and step through the process that leads to a computer's capability to do this. This is just one example of an AI, taught by machine learning, that's able to see objects in a video and automatically classify the object and track its motion in real time. This might seem like a simple feat on the surface, but in practice it's quite complex, taking millions of images and tons of training time to learn, and the amount of math involved is enough to make any mathematician's brain explode. Let's talk about cameras for a minute. They're the eyeballs of computers. First, let's take a second to appreciate the fact that I'm recording this video off of a camera the size of a pea. And right now it's capturing everything in my office as light reflects off of it in this precise moment in time in full 1080p resolution. But what does that mean, 1080p? We've heard people talk about resolution regarding televisions and monitors, 1080p, 4K, Ultra HD, Retina display. We've also heard people talk about megapixels when they're talking about cameras, 24 megapixels in a DSLR, 8 megapixels in your smartphone camera. But what's this all referring to? A pixel is a single dot of color, and we use thousands or millions of them to make up a picture. This is an Eevee. This is a pixel. It takes close to 18 million pixels to paint this lovely picture of Eevee. Each pixel has a color value, meaning it's a mixture of red, green, and blue. This is how computers see pictures. A picture is just millions of dots, aligned just so, each of a different color, and it's by analyzing groupings of these pixels that computers are able to add context to a picture. Machine learning uses something called a convolutional neural network to understand patterns in images and learn how to identify objects. These networks mimic the animal visual cortex, which we all have, which is the part of our brains that receives data from our eyes and interprets that data. The first step in computer vision is to group similar colors together to recognize potential objects like so. From there, its job is to find the edges within the image, to ensure it's separating like colors as well as identified curves and edges to be able to accurately identify individual objects. Now that we have different patterns mapped out to represent a physical object, we need to label that pattern to represent a tangible thing, like a glass or a computer. To do that, we need lots and lots of pictures. Pictures that humans have labeled, indicating to the computer if it's a cat, a dog, a fire truck, or the Taj Mahal. Once our AI has seen enough pictures of a cat, it starts to recognize similarities between patterns, similar to how we do. Cats have 2 eyes, 4 legs, 2 ears, they're furry. And while all of those things are true, they aren't helpful in identifying a still image. So we need to cover all of our bases and make sure that we've shown our AI enough pictures of cats in all of their unimaginable positions to be able to account for whatever ridiculous poses a cat may find itself in. So let's jump into a real-life example of computer vision in practice. This is Tesla's autopilot AI, driving down the street, identifying cars, signs, pedestrians, stoplights. It's doing this in real time because a 1-second delay in object recognition could mean the difference between stopping at a stop sign and getting T-boned. But again, some of the magic gets lost in a video like this because all we see are boxes around objects. But in reality, the computer is taking HD video output, breaking it down into millions of pixels, recognizing patterns in the pixels, remembering what each pattern might mean, and then labeling the object as it tracks its motion across the screen. In this particular instance, the AI is then telling the car to stop, accelerate, steer, or cruise, which is a whole nother ball of wax. Self-driving cars aren't the only possible applications of computer vision. Doctors spend a decade in school and are paid very well for their ability to accurately spot malignant cancer in MRIs, CAT scan, and other images. Insurance adjusters and appraisers also spend a lot of time determining the severity and cost of repair from pictures of cars that were in accidents. The entire world is captured by photos by satellites in space and analyzing all 510 million square kilometers of the Earth for information on climate change, natural disasters, and land use would take hundreds of people many years to review, when a well-trained AI could do it in hours or days, depending on computing power. So, what opportunities are there for AI and computer vision in your industry or area of interest? Do you or your colleagues spend time looking at pictures, and is there any way an AI could help with that? Let me know in the comments below. Thanks for watching.